Okay, this next video is on testing capacitors. Capacitors are very, very important. If you don't have a good capacitor on your motor, it's very likely that it will not operate correctly. If it's not a good capacitor on your motor or on your compressor, it's very likely that it will not operate correctly. This capacitor is a 12.5 microfarad capacitor. Now, what that means is that it should have 12.5 microfarads between these two terminals. So what I use is a microfarad tester. I have one right here on my meter. As you can see, it's only putting out 11.5, 11.6. It should be 12.5. The tolerance that's allowed on these capacitors are usually plus or minus 6%. So what that means is we can have a reading less than or greater than 12.5 microfarads, so long as it's within that 6% variance. This is a 12.5 microfarad capacitor. We're getting 11.6 on our microfarad tester. Okay? What that means is that this capacitor is out of tolerance, because 6% of 12.5 is 0.75. So that means we can have, if it were 11.75 or greater, it would be within its tolerance. But because it's 11.6 and it's fluctuating between 11.5 and 11.6, I know that this capacitor is out of tolerance. So, having said that, it's best to change it, and the reason why is because the capacitor is what assists the motor in starting. If the motor does not have the assistance required in starting, then it puts more wear and tear on your motor. And if you look on the motor itself, it'll actually tell you what type of capacitor is supposed to be on here. Now this one I can't see it, but I'm assuming since this unit has not ever had to have anything replaced on it, I'm assuming that that's the manufacturer's capacitor. So I'm guessing on this motor you would find 12.5 microfarad capacitor on the motor. There's lots of information on this motor. It tells the voltage, 208, 230 on this particular one, and it also tells you how many horsepower it is, as well as RPMs, max amp draw, so on and so forth. This one has a max amp draw of 2.7 to 3.6. So if you check this motor in low speed or high speed or whatever, it should not have amp draw higher than those specified on the label, which this one says 2.7 3/3.6. Anyway, that's a little information on capacitors. If you have a unit that's not operating correctly, if it's not working, a very good likely thing, if you haven't had service on it, is to check your capacitors and see if your capacitor is within tolerance. Of course, you would have to have a microfarad tester to test it, but a number of problems on units are caused by capacitors. Even inducer motors, some inducer motors have capacitors. So it's best to check those capacitors, and it might save you a little bit of money in the long run, because you won't have to call a contractor out there. Capacitors usually run about $5–6 at the most for the smaller ones, and they're on washing machine motors as well. If you call a contractor out to take a look at your unit, you're looking at about, service call of $65 plus the price of a capacitor. I've worked for some that charge $89. I work for them out of necessity, not out of desire. But in that essence, you're looking at about $145, $150 when you could be spending $5 to fix it yourself. And of course, it's a very simple fix. So, to make a long story short, that's a little bit on capacitors, always make sure and shut off the disconnect switch if you're dealing with an air conditioning system or a heating system. Make sure you turn the breakers off or power to it, because if not, then you'll electrocute yourself. Also, make sure that if you're dealing with a washing machine, make sure you unplug the washing machine before you check the capacitor. Once again, this is a short video on capacitors and tolerance. This capacitor in particular is 12.5 microfarad, plus or minus 6% tolerance. We're getting 11.5. I'm going to go ahead and replace it. Thanks.